Hello, welcome to Ekidel, where I will train future civil and structural engineer. My name is Justice Umoka. I am your instructor. Today, I will be showing you how to design a raft foundation using Protastructure. So by the end of this lesson, you will be able to design perfectly a raft foundation here in Protastructure. Okay, so let's begin right now. So this is a school building, as you can see right now. This is a live project, and this is a school building. So we are done with the design of the superstructure. So right now, we want to now go and design for the raft for the foundation, and the choice of the foundation that we want to use is a raft foundation. The reason is because the bearing capacity of this building is 65 kilonewton per meter square. So we have tried using pad foundation and it was not working. It was failing. There was punching, and even if we have also tried to increase the depth of the pad foundation and it's still failing. So we now decided to use a mini pie, which is a pie foundation, which and as you know, we have two types of raft foundation. We have beam rafts and also slab rafts. But on this training and also on this building, we want to use a beam raft for the foundation of this building. So right now, to begin a beam raft foundation, the first thing to do is to go to your plan view first. Now on your plan view, you can see that this is the story 1, so you have to go to story 00 and make story 00 active. So when you come to story 00, you will be left with only your columns, as you can see it here. Now since we want to use a beam raft, we will now begin to now insert our beams, which is also called ground beams. Okay, so right now I will now click on this place, concrete member, and then click on concrete beam, and then I will now go, once the dialog box appears, I will have to now go and impute my ground beam properties, which I want to use 225, as you can see it here. Now the depth, I want my beam depth to be 1400. So I'll just go there right now and put my beam depth 1400, and then I'll now begin to draw my ground beam. Just the whole idea is to connect let your ground beam be connected from column to column. So I want to make it to flush. You can see that this beam is not centralized, so I'll just go here right now, make here to be 0, and then go here right now and then click on this place. Okay, so right now this beam is now centralized. Okay, so I'll just go and then click on this and then begin to connect all my columns together using the ground beam. So the whole idea is to check what the kind of plan you how you connected your beam on the ground floor, and then do the same here. Okay, so I'll just do again. I'll now click on this from here to here. Okay, that's fine. And also click from this point to this point, and then from here to here, and then from here to here. So always connect your beam during your raft foundation column to column. Okay, so I'm doing that just now. So you can see that we have different sizes of column. You can see that we have column of 450 by 225. That's because the load on this building is very high, because this is a school building, and we all know that school building using we use the BS code for this design. Like I said again, this is a live project, so you can see that we have already checked all our columns, and you can see that some columns are bigger than the other. That's because we have checked these columns, and we have seen that this is the exact size that will be able to carry the load on that area. Okay, so we are now beginning to connect our beams together. Okay, so the whole idea is to connect your beam together. So there is what they call Ekidel mentorship class or program, which is a special training where we train civil and structural engineers, especially not here on a YouTube, where we use a live screen casting where you'll be able to see us, and we will now guide you on what to do. It takes only 4 weeks, and the price of it for now, we are giving discount, is just $300 for the 4 weeks. But I tell you, you're going to learn a lot, because we will train you across all aspect of structural design, both in steel and also in concrete, and also detailing. Okay, so if you are interested, I would say check on the link down below, and then join our Ekidel mentorship class. Okay, so right now I'm done with this place. I will now begin to connect this one also. I'll connect from here to here, and then from here to here. Now, if maybe you get confused along the line, you don't know how the beams are running, you can just go here and then navigate from this place to the first floor and check how your beams are. So let me just go and check if I'm really following what I have. Now, the other best way is to use your phone and then snap the way you have drawn your beam here, and then go out to the 0 and draw your beam perfectly there. Okay, so right now let me just check what we have. We have beam along this side, and then here. Okay, let me just go back to 0 right now and then go and draw my beam there. So I'll go here right now again. So we concrete beam, okay, member and beam, and then okay, so I have from here to here beam. Okay, so right now let me now begin to tell you theory about Raft Foundation. Now, before you must make your choice, we have different type of foundation, beginning from a pad foundation, which is called pad footing, or most people call it footing foundation, but the right name is pad foundation. So the first thing you have to consider when you're designing for your foundation on building is a pad foundation. That is if the building is not more than 4-story building. The first thing you should consider is to use a pad foundation, and that is only if the bearing capacity of that building or of the soil is up to 75 kilonewton per meter. So once your soil bearing capacity is up to or more than 75 kilonewton per meter, the first foundation type that should come to your mind is a pad foundation. Then it is when you have tried that and there is a failure, you can now go ahead and go and use the next one, which is called a strip foundation. And when a strip foundation is not sufficient, then you can now go ahead and now go and use a beam raft foundation. And when a beam raft foundation is also failing, you can now go and use a slab raft foundation. And when that is not failing, you can now use the final type of foundation, which is a pie foundation. Okay, so here on Ekidel, we will be teaching you that last year we did more on a pad foundation. So if in case you missed all our videos on pad foundation, I would say you should go and watch our videos and you will learn a lot on how to design a pad foundation. So this year, we want to train you on a raft foundation. So we will be doing more buildings on a raft foundation, and by the grace of God, we have been having contracts on building design, and all our buildings contract that we have been having is on a Raft foundation. So that's why we are using a live project to teach you on that. And it is always good to use a live project to teach anyone that you want to teach, because we believe that it is only when you use a live project to teach someone that they will be able to have confidence on what they are learning. Okay, so let's just begin right now. So the whole idea right now is to connect all the connect all the beams, all the columns with a ground beam, which I'm doing right now. Raft foundation always takes time, but I'll say that you should just pay attention to what I'm doing right now, and in less than few seconds you'll be able to grab everything. Let me just check how this place is. So I'll navigate right now to story 1 and then check what I have here. Let me just take story 1. Okay, let it just come up right now. Story 1. Okay, there is, okay, here I don't have a beam crossing here, so I'll take it off. I'm just doing here to get down to here. Okay, that's fine. So I'll just go that way right now. I can just go take this off right now, and then go concrete beam. Cross check if your settings the beams are still okay, which is okay for me here. So I'll go here right now and then go locate here and put my beam across here, and then from here primary beam go up right now, secondary beam, sorry, go here and then put here. Okay, that's fine. And then what do I have again? Let me check how this place should be connected this way. Okay, that's fine. And then let me see how this place is. Now get to story 1. This place must be connecting this way or this way. Let me see how this place looks like. Okay, so you can now see how, okay, there is a beam crossing here. Okay, that's fine. So I'll go back right now. So the whole idea is to cross your ground beam on all the places where you have your walls passing through, or connect your ground beams to join the columns together. As you can see how I am trying to navigate each other to see. Let me see how this arrangement is on the beams arrangement on the first floor here. Let me see what I have here. Okay, let me just navigate. Okay, let me just see. Okay, I have a, okay, I can choose to ignore this one. I can choose to not this one, because this panel is not big. This panel is 5.025 multiplied by what length? 5. That's around 25. Sorry, that's around 25 square meter, which is not up to 30. That's fine. I can spare that. I can leave that alone. Okay, so I can leave that as a panel, and then I'll now go and then let me just check again how here is. Okay, that's fine. So I'll go here again right now and then try to work on this place. Go to my concrete member, concrete beam, and then connect this to this. So Raft Foundation always take time, and I'll see that when you're doing a Raft Foundation, don't be in a haste, because if you're in a haste, you might miss some things which you're meant to consider. So always take your time and then perform that very well. Mainly the modeling, because if you are wrong on your modeling, then during the design you'll be having errors or issues on your Raft Foundation. Let me connect this. I think this should be this way, and then I don't know if this is how it looks like here, but I believe that's how it will look like. So connect this to this, okay, and connect this to this. I'll check that first if that's how it looks like. Okay, that's fine. I'm going to story 1 to check that out. Okay, let me just check that out. So 31, if that's what we have. Okay, yes, that's fine. Then the beam cross is here too. Okay, that's fine. So I'll go back to story 00 where the graft is, and then connect this again together. I can click on this beam right now and then take the beam properties. So I will not click here. I'll just take it property right now and then begin again. So you can choose to click there or just do what I've just done right now. The whole idea is to be fast in your modeling. Okay, so I've done this area right now. Let me now go and check it again, what I have again, how this place looks like on the modeling. Let me just, on the story 1, how the beams here are connecting. Let me just check again here, what's happening here. I believe this comes to this place. Let me see. Okay, there's a flowing here. Okay, that's fine. I've seen that. That's good. So I'll just go right now and click on story 0, sorry, and then click on maybe. Okay, let me just go here. Click here, and then concrete beam. Then I'll now go here again and then connect this first to join here, and then I'll move on to this place right now from this to this. Now I am pressing escape, so you have to press escape once you want to shift, maybe change your beam direction. So I'll and here, let me just click here. Yeah, it's joining this way. And then let me see how big this panel is. Now you can see I'm checking each of my panel. A panel must not be bigger than 30 meter square area. Okay, this is 5.625 multiplied by 5 point something, which is less than 30 meters square, because 60 and 30 will give you 5 times 6. So since none of the length is up to 6 meters, so that is fine. Okay, so I can take this right now as a panel. This is what? This 5.25 multiplied by 5. That's fine. So right now I am done with my grand beam. I can see that my grand beam arrangement, as you can see there right now. I can choose to connect here together just to make this place more stronger. I can choose to connect this beam together here, just to make this connection stronger. Okay, that's fine. I can choose that. But if you check in our upper floor, here was a staircase, so we left here as void. But here on the Raft Foundation, we don't consider anywhere as staircase, because everywhere must be slabbed with okay, that's fine. So let me do it again. I can connect this one to make it more stronger. Also, I can go again here, put my beam here, and then connect. The whole idea is to connect all your columns with a ground beams. So that's why I'm doing just that just now. Okay, so again, that's fine. So right now we are done with our modeling on this place. Let me just check our plan view. We are done with our ground beam connection. You can see that 3D view. So you can now see how our 3D view is right now. So we will now go and can see that this story tends to be small. So we will now go and add the height of that of our DPC. So go to this place right now. This story, that's fine. This story, we can add DPC level at least 600. Let me see if it's not there already. Now, if it is there already, then I will have to go and increase the headroom of this building, because this is already 1.4. So let me just open that up. Okay, we already have we already have DPC level as 600. So I'll increase the first floor to be 3.300. That's fine. Sorry, 3.3. Sorry, 3.3. So I'll put that just now and then click on OK. Okay. I'll just say yes. Continue about that. I'll say yes. Cancel analysis. So I'll just continue right now. Okay, can I see that there is a lift now on the headroom? Okay, that's fine. So we will now go, since we have done that, it cancelled all what we have run before, which is the structural analysis. But first of all, let me go and show you how to put our slab raft. Now go back to our plan view right now. To put your slab raft on this bin, you have to click on this place and then go to slab. Now pay attention, the way you insert your floor slab on your superstructure is different from the way we insert our slab raft, like our slab on the beam raft foundation. Now, first of all, your depth, your minimum depth for raft foundation should be, for slab, should be 200, and then cover, since I'm using BS code, I'll use 50 for foundation cover reinforcement. And then on this place called load here, you have to take this place notes relative level, because if you don't put this value, that means that your slab we're going to stay at the bottom of the beam, which is not supposed to be so. So if I just insert right now without putting the value here, if I check on our 3D view right now, you will see what will happen. This slab will not be at the top, but instead at the bottom, which is wrong. So this slab, you can see that there is a slab here, but it is found at the bottom here, as you can see it here. Now this slab is meant to be found at the top of this place here, of this place. So right now, to do that right now, always always add your slab relative level only on raft foundation and not on the first floor, and not on the superstructure. Only on foundation level you put that value. So I'll go there right now and edit that slab, just this one for the foundation, and then go here and then put my value here. Now, how do you get this, what they call relative level? How do you get the value to put here? The value to put here, we get it by the height of this beam, minus the depth of the raft slab. So the height of this beam is 1.4 minus 200, which is the slab thickness. That gives me 1.2. So I'll put there right now in millimeter. You can see it there, 1200 millimeter, and I'll click on what update. The slab will come up now immediately. You can see that right now. So if I click on escape just now, you can now see that escape here. You can now see how this is now how our slab raft is, our slab on raft foundation is meant to be. You can see there. Now this space between the soil and this slab here on this foundation, this void inside here will be filled with a sharp sand during the construction. Okay, so that's how it is. So right now, I will now use the same procedure to now begin to insert for all my slabs just now. Okay, like I said again, you use a raft foundation when your bearing capacity is below 75 kilonewton per meter square. Now, in this case, the bearing capacity of the soil which this building is to be sited is 65. That's why we chose our choice of foundation to be as a raft foundation. Else, if the soil bearing capacity of this building was above 75 or 75, we would have used either a pad foundation or a wide strip foundation, which I'll also show you a wide strip foundation because we have not done that a lot here. Okay, so I'll just begin to insert my slabs, just confirming that I still have my level here. Okay, that's fine. So I begin to insert my slabs just now. On everywhere must have slab on a raft foundation. So I begin to input in my slabs just there right now. I'll just pan right now to see everywhere and then begin to put my slabs here. Okay, that's fine. So I'll now click on what they call escape here. Okay, and then once I click on escape, let me now show you on the 3D view what we have just done just now. So if you check on our 3D view right now, you can now see what we have done. We have successfully modded our raft foundation, as you can see there. Let me just turn off this grid line for you to see it clearly, and then also, okay, so right now you can now see what we have just done. We have now modded our raft foundation, as you can see there. Now there is something they call toe. Now in BS code of practice, once your beam is more than once your beam depth is more than 900 millimeter, once your beam depth is more than 900 millimeter and it's up to 1 meter upward, that beam should be designed as a retaining wall. Now this beam right now, the depth of this beam is already 1.4 meters. So this beam, this raft beam right now,
appears to you as a beam, but you are meant to design it as a retaining wall. So in that case, and the way we design a retaining wall is by using a toe at the bottom of that wall. So right now, I'm going to add, since this beam depth of this raft is 1.4 meters high, I'm going to add a toe. The reason for that toe is to be able to resist, is to be able to resist what they call overburden pressure, or you can say active pressure, that we're going to affect this beam at the bottom. So I'm going to apply what they call toe on this Raft foundation. Most people don't do it, but like I told you, we follow guidelines and what is what is there on a BS code. So let me just show you right now what I mean by toe. So I'll go right now on the plan view right now to make a model my toe slab for still on the Raft foundation area. So right now I'll just go this way just now and then click on my slab here, and then click on the slab here, and then on the slab right now properties, I'll still pick here as 200, which is what what we used here. You can see there, and then cover to be still 50, and then on this 50, and then on this place right now, you have to leave this place, this place here as 0. Don't put any value here because the slab is meant to be at the bottom and not at the top, which is that toe slab. Okay, I'll now go to this place right now and choose my type of slab here as 2F. It must be 2F, else it will not work. So once you pick 2F right now, on this place called length of cantilever, which is L cant, you have to a toe slab, the length of toe for a retaining wall starts from 500, so 5 to 1 meter. So in just not to avoid any coming back to come and now repeat what I've just done, I would advise you just use 1 meter, which is the maximum, or you can stick yourself to 850, 750. But in this case, I'll use 1 meter as my length of cantilever, and I'll now click on this column and then click here, and then insert, and then click outside here. Now we have just gotten our first toe. Let me just do for this line just now and then show you on 3D view how it will look like. Okay, so let me just do again from here to here, and then click here, and then I'll now click on what they call escape here, and then let me just show you how it looks like on 3D view and on the 3D view, and then we can now come back to and continue what we are doing just now. So if I want to rotate this place right now, this is what they call a toe slab. Let me just turn off my grid line so that you can see it very clearer. Okay, I turn off my grid line. Okay, now this is what they call a toe slab. This will help to take care of what they call overburden pressure at the bottom of this base. I will also show you how the reinforcement detailing will be, which we are going to use the Stonebridge, the new release of the Stonebridge company structural template, which is a customized template for detailing after you're done with Protastructure. Okay, so if you want to know more about the template, I would say you should check all our structural detailing videos, and you will see how that template is wonderful. Okay, so I'll just continue right now to now begin to put my toe slab on all the place where we have ground beams on the raft on the foundation level. So I'll go here right now, plan view again, and then begin to, I'll just click on this one right now, right click, and then begin to put in my take my properties and then begin to insert that just now. So this way right now, I'll model from here to here and then click outside, and then from here to here and then click outside. I'll now do it very fast, just to be very fast. I'll click from here to here and then outside, and then from here to here and then outside, and then from here to here outside. Okay, so you cannot see what I'm doing. So Raft Foundation always takes time. So when you're charging for Raft Foundation, always charge it very high. The same rate, let me say you charge for design for a part foundation, let me say $300 or $200, you don't have to charge that the same price for Raft Foundation, because Raft Foundation takes time. So you can charge up to $500 for Raft Foundation. So if maybe you want to contract us for your structural design, we are always open for that kind of service to also design for you, if maybe you want us to perform your design for you, and also your detailing for you. So you can pay us for that, and then we will assist you on your structural design work, okay, and also projects. Okay, so I'll just do this right now and then continue again. What I'm doing right now, do this and then do this and then continue from here, put here, Okay, so the whole idea is to put all this toe slab on everywhere you have this ground bin, which is the raft bin. Okay, so I'll do this right now again, and then do this, and then do this, and then do this again, do this again here, and then continue again, continue here again, continue here again, continue again, continue again, and then continue again. So I'll do this again right now, continue from here, continue here. Okay, that's fine. And then click here and click here and then click here. And then continue again from here, click here and then click here and then click here. And then continue again right now, click here and then click here. Okay, sorry, that's bad. Let me just continue from here, click here and click here. Okay, I'm going to just to redo here after I redo that place. So I'll continue again from here to here and then click here and then continue from here to here and then click here. Okay, and then click from here to here and then here. Okay, that's fine. So let me now redo this place right now. So I'll just click on the escape first and then delete this slab, this one first. I am meant to insert this and small one first if I can insert that one. So I'll just delete that first, this one now, and then go back and take this one property, right click and say properties, and then insert this one first, insert from here to this place, and then continue again from here to here, click here and then click outside. Okay, that's fine. So this now, let me now show you the 3D view of what we have just done just now. So if we now go and check on our 3D view just now, and then click on 3D view and then 3D view here to now see what we have just done. So you can now see that, let me now turn off this grid line for you to see it clearer. So you can now see that we have successfully modeled our Raft Foundation, as you can see there. Like I said again, the first part of this video will be on the modeling. So this is the part 1 of this modeling. So you can now see that we have successfully modeled for this Raft Foundation. So this is how to model a Raft Foundation. Now part 2, which will come up immediately after this video, will be on the Raft Foundation analysis and design, which I will show you the settings you're meant to do before you can perform your Raft design in Protastructure. Okay, so right now you can see that what we have just done so far is very beautiful. So this is how to model a Raft Foundation, and I've also told you the theory that you have to take or what to consider before you can choose your choice of foundation as Raft Foundation. Okay, so if you have any questions so far for what you have done for now, I'll say you should just do the question on down below the comment section, and then we will reply you immediately. Okay, so thank you so much, and this is the part 1. So watch out for the part 2, which will now be on the Raft Foundation design and also analysis, and then the part 3 will be on the Raft Foundation detailing, which I will show you how to detail this toe slab and this beam and this slab reinforcement together, how they will look like. Okay, so right now, thank you and God bless you. And watch out for the next. We love you and I will love you again. Okay, bye. Hello, welcome to Ekidel. We are a trained future civil and structural engineer. My name is Justice Onwaka. I am your instructor. Today, I'll be showing you the Raft Foundation design for this school building. So this is the part 2 of this Raft Foundation design. Yesterday, we did the part 1, which is to model this Raft Foundation, where we have to model this ground beam and then also model this raft slab here, and then now model for this slab toe under this place. So if maybe you missed the part 1, I would say you should check on our channel or check on the link down below and watch the part 1 of this Raft Foundation design. So today, this is the part 2, which will now begin the Raft Foundation analysis and design. So right now, let's get started just now. So for now, to begin the design for this Raft Foundation, I'll go onto this place first and go to plan view, and under my plan view, I'll be on story 0. As you can see it here, story 0 is for foundation. So first of all, I'll turn on my grid lines. I turned it up before just to give some clarity so that you can be able to see the 3D view modeling very clear. So right now on this place just now, the first thing to do again, once you reach this stage, once you come to this place, before you begin your Raft Foundation analysis, you have to draw what they call slab strip. So I have to click on this place right now, on this place, concrete member, as you can see it here, then go to this place, slab strip. Now, on the superstructure, which is for the first floor or second floor, you have to finish your design before you can now draw your slab strip. But for Raft Foundation, after you finish modeling your Raft Foundation, like placing your beams and your slabs for the raft beam and slab, then you have to cut your strip first before you can begin your Raft Foundation design. If you don't cut your strip first, then after your design for the Raft Foundation, you won't be able to cut the strip again because you won't be able to see the reinforcement of the Raft Foundation slab. So right now, I'm going to cut the strip. Now, the way we used to cut strip on the superstructure, we used to use this type, which is called Atlantica slab. But for our foundation, we used to use FE strip, which is finite element method of strip of slab detailing, which is strip. So I have to go here right now and then click on this place, FE strip. So this is used for only Raft Foundation or for a flat slab design. So right now I'm going to use this one here, FE strip, and then once I do that, I will check my X direction, as you can see it here, and then now I will just cut. I will pick this place and this place here. Now, since this toe reinforcement is not the same thing with this slab raft reinforcement, and since they are of the same level, that means they will not detail the two together. So I'll have to start my cuttings of the slab detailing from this point and not at this edge here. So I'll quickly start it from the very point once I pass the slab, this beam here. So I'll click at this point just now and then go over to the next point since I'm cutting X direction, and then go hold my control key to make my line straight, and then I'll hold my control key and then click at this point here. Okay, so right now I have cut my X direction. I'm not going to cut every panel because the whole idea is just to get the value of my slab reinforcement spacing and also the size of the reinforcement. Then once we get these two values, we will now going to use the customized Stonebridge, the customized Prota structural detailing template, which is the Stonebridge template, to now perform this Raft Foundation design, which I will also do on the part 3 on the Raft Foundation detailing. So we are going to use the Stonebridge customized structural templates for detailing of this. So if maybe you need that template, you just check on the link down below. I'll also drop the link for that template also, so that you can be able to follow up together. Okay, so I'll just go again right now and click on this place here. I'll now cut for the Y direction. I'll do the same thing again. Go here and click up here, and then go over to this very down place here. Hold my control key down, and then click at this very point here. Okay, I can just cut again on X direction and cut this other one. I can cut from here again to this very place here. Okay, for X direction, and then cut also this panel again. The whole idea is just to get my slab reinforcement design reports and also the spacing and the size. Then we will now use the Stonebridge detailing template to now perform the Raft Foundation detailing. Now, Stonebridge detailing template is a customized template used for structural detailing after you're done with Protastructure. It works perfectly well with Protastructure. In fact, it was customized basically for this software Protastructure. So if you need that, check on the link down below. It's not free, but it will help you a lot because it will have to reduce your work to at least 80%. Okay, so right now, once we are done cutting this slab strip right now, the next thing to do, I'll have to save first. So always save so that you will not have to lose any of your job in case the software runs into runtime error or shuts down. Okay, so on the part 1, I said that for you to choose a Raft Foundation as your choice of foundation, that means that the bearing capacity of the soil is very low. And for you to make a choice of Raft Foundation, your bearing capacity must be lower than 75 kilonewton per meter square. So once your bearing capacity is lower than 75 kilonewton per meter square, then you have to make a choice to use a raft foundation or a strip foundation. But the best choice to make is to use a raft foundation. If it is for a bigger building, use a raft foundation. If it is for a very small building, you have to use a wide strip foundation. And if that is not, if that wide strip fails, then you can now go ahead and now use a raft foundation. Okay, so right now we have cut our strip X and Y direction, and also we have also saved. So right now I will now go to this place here called analysis, and then click on this place here. This one here, finite FE, which simply means finite element, as you can see it here. FE, Raft Foundation Analysis. So I'll click on this place right now and wait for the dollar box to appear. So on this place right now, I'll just check these three values here, these three checks here, and then leave here as default, because this is the average surge charge. So I'll just go here right now, leave here as default as it is there. It's good as default, and then click on this place here, Raft Foundation Mesh and Analysis. So I'll click on this place here right now. Don't click on this space over, else you begin to have pause on your design for the Raft Foundation. It now begin to pause on each level. We mainly use this if you're designing for a super, let me say for 10-story building, 15-story building, for a high-rise building, then we cannot use this. That when it gets to that, it can only it will be performing the floor analysis level by level. Okay, so right now, once on this stage just now, we'll now click on this place here called generate model. So I'll click on this place right now, leave these two values as default, leave them, just click on this place, generate model. So once we are done with creating the mesh model, we will now move on to the next stage, which is the post analysis and design. We will now have to click on the contour and then begin to check for our bending moment, and also check for our area of steel for the bottom and also for the top, and then go ahead now and check our soil pressure, where the building pressure must be less than the soil pressure. Once the soil pressure is more than the building pressure, once the building pressure is more than the soil pressure, then it shows that there is a failure on your raft foundation. But once the soil pressure is once the value of the soil pressure is more than the value of the building, of the pressure due to building, then that shows that your raft foundation is okay. Don't worry about that, don't panic about that. I will just show you all that what I've just said right now on this design. Okay, so there is what we call Ekidel mentorship class. So if maybe you are interested to like enroll for our special training, then you can just check on the link down below and then click on the link which says join our Ekidel special mentorship program, and then we will train you specially for the design of structural elements. Okay, so right now, once you're done this stage right now, you can see that it has shown that mesh generation completed successfully. So right now you have to now click on this place here called close, and then once you click on that, you have to wait for the next stage to open. Don't click on anything. If you click on anything, the software will tend to misbehave. So wait for the next stage to open. Okay, so just hold on. Once it opens, this post analysis here will be activated. So just hold on for it to open, and when it when it opens, you will be given the chance to put in your soil bearing capacity, which is called in this software reliable soil bearing capacity. So you have to wait for it to load up to the next stage. Don't click on anything and then wait for it to load. Okay, and then you will also see what they call positive moment and also negative moment. Leave those two values as it is, 1 just impute your soil bearing capacity, which I have said already in our part 1 that you have before you make a choice for a raft foundation, that shows that your bearing capacity must be below 75 kilonewton per meter square. Once it is above that, you have to use a pad foundation or a different kind of foundation. But once it is below, you have to consider using a raft foundation or a wide strip foundation. Wide strip foundation is what you should consider first. Then when there's a failure, you can now go ahead and now design
for a Raft foundation. And when Raft foundation fails, you can now go ahead and now design for a slab raft. There is what they call beam Raft foundation and also a slab Raft foundation. Slab Raft foundation is the last foundation you will consider before you can now consider a pie foundation. Pie foundation is the last type of foundation that you can use for the design of structural elements. Although there is also what they call a strap foundation, but that's not common. I will tell you when to use that as we go ahead on our videos. Okay, so right now you can now see this place called allowable soil stress, which simply means the bearing capacity of the soil. So in this case, the bearing capacity of this soil is 55. So I'll quickly put in the value right now, as you can see there right now, 55. And then once I put in the value, I have to click on this place here called analysis post-processing. So click on this place just now, leave these two values as 1, 1, and then click on this place. Okay, so right now, once you click on this place right now called, then just hold on for it to load the next stage. Now the next stage is what we do is where we are going to deal with the soil pressure against the building pressure. Okay, so let's just hold on for it to load just now. So if you have any comments from what we have done, if you have watched the part 1 and the part 2 and this part 2 right now, and you have any questions so far for what we have done, I would say that you should just drop the comment down below. We have been answering comments since we in all our videos, so just drop the comment down below and then we will just reply you ASAP. Okay, so thank you, and then let's just wait on for this stage to conclude. So now once this dialog box, once this meshing environment is okay, you will see all the yeah, this is how you see it. So everything now looks okay. So the first thing, once you come to this place, I would say you should just click on this place called contour. You can see that we have different contours here, but this is the one you should click, called standard contour. Don't click on this one and don't click on this one. Just click on this one here called standard contour. So I'll click on it and wait for it to load. Now once it loads, you will see this thing here. Now this is what you should be looking at as we are about to enter the next stage. So once you have clicked on this place just now and then begin to click here, as you can see it here, begin to click here now. I'll click here, and then once I click here, I'll allow it to load into this model here. So whatever thing you click here, you have to allow it to load. I'll click again on the next one again, and I will allow it to load. Now put your eyes here, you'll be seeing the values of everything we are clicking here. Right now we have clicked on the MX and on the MY, and you can see the value of the moment at Y and also at X. You can see this red one here shows the maximum value of what we are going to click, and this first value here shows the minimum. So always put your eye at the maximum, because in design we design for the worst condition. Okay, so right now I'll click again on MS and MY. We are going to be dealing with this when we enter this required steel area of steel. Okay, so but you have to pass through this stage first before you can now get to this place. So I'll go now and click on M1 and then wait for it to load, and then once it is done, I'll now click on M2, and just that way sequentially. So I'll do the same thing right now for M2, and then go again and do the same thing for M1 and M2. Now this is a live project, as I said on the first on the part 1 of this video. This is a live project. It is a school project which we are designing for a client. As you all know, here on Ekidel, it's our culture that we use a live project to cheat, because we believe that it is only when you use a live project to teach anyone that the person will have confidence for what he or she is learning. So that's why we use mostly live project to design. Okay, and God has been helping us. We get projects almost every week, so that's why you see us making videos almost every week. Okay, so we go again right now and then click on this place and then click now. So once I click here right now, I will be able to see the area of steel on the button. So I will be now you can now see that the maximum area of steel that we have is 1206, as you can see it here. So with this right now, let me just continue and then click on this place. Now if you check on your slab reinforcement table,
which I believe you should have, you can be able to relate the you can be able to relate what spacing of reinforcement and the size of reinforcement that you will use. Although, because we have already cut strip before we get to this stage, I will show you how to produce that, how to see that reinforcement. Okay, so right now I'll click on the top one right now because I've already clicked on the ND2 button, as you can see there. So I'll click on now. If as you're clicking here, if your slab depth was not sufficient, you will be seeing error. Once you get to this area of this stage, once your slab thickness is not sufficient, you will begin to see error like insufficient depth errors. So once you see that kind of error, you have to go and then locate that slab and then increase that area of slab or increase the slab thickness generally only for the raft foundations. Okay, so I will go again. Okay, I've already clicked here. Let me allow it to load. Okay, now it have load. Now we will now go ahead and then click on the soil pressure. Now this is where you should pay very good attention for the soil pressure. You can see that. So this is the last one that we are going to click, which is this soil pressure here. Don't click on this soil pressure threshold. This soil pressure threshold, you are going to use it if you're using this threshold contour. But since we didn't use it, since we're using only this first contour, which is called standard contour, you have to stop you have to stop whatever thing you are designing on this soil pressure. Now this is the only place we are going to click, and then we will now begin to relate between the soil pressure and the building pressure. So I'll also show you when now it is on this soil pressure, you will be able to know if your raft foundation is failing or it is passing. So let's just allow it to load. This stage alone takes a lot of time. This soil pressure, you can see how all these ones we are just loading one by one. It didn't take much time, but this soil pressure can take you up to 30 minutes. And if your system is not that strong, or your system capacity or your system RAM is about to be filled up, then you have to wait for sometimes 2 hours, 3 hours. And if the building is very, very massive also, this stage alone will take you longer time. As you can see that this building is already 35 meters by 25 meters. So this building alone is a big building. So that's why you are seeing it taking time. But we will just hold on for it to load up. So once it is being loaded up right now, I'll begin to show you how to check how to know if your raft foundation slab is failing or not. Okay, so let's just hold on for it to load right now. Okay, like I said again before, if you have any question concerning for what we have done so far, I would say you should just drop the question down below. We have also dropped also our WhatsApp number down on this video description, so that you can also chat us up if you have any kind of confusion, and then we will like guide you through. But our advice, if you can afford it, it is only $200. We are giving a discount already for $300 for our special Ekidel mentorship class. So if you can afford that, that will be better, because we will teach you both manual and also practical, and then also teach you with software. Okay, so right now you can now see that the soil pressure has now been completed. So to know if your slab is failing, you can put your eye, you can just carry your cursor and hover around any of this place, or anywhere around this building right now. As you can see that the soil pressure first, you can see this place, this is the soil pressure based, this pressure you're seeing here is the soil pressure based on the structure load. Now this is the soil pressure, you can see it here, all these values here is the pressure based on the structure load. Now the pressure based on the soil bearing capacity which you provided, look at it here, this one here, this is the, okay, so let me just hover again right now to see again this side again. Sorry, so this one here which is showing 77 is the soil pressure based on the bearing capacity of the soil which we provided. I don't know if you get me. Don't forget that we used 55 as our bearing capacity value. So since we are using a BS code of practice, so multiply 55 multiplied by the factor of safety of 1.4, that will give you this 74, this 77. So 77 is the soil pressure due to the bearing capacity. Now this pressure here is the pressure due to the load, the weight of the building on the soil. So how to know that your foundation is not failing? One is this. Once this value here, which is the maximum value here, which is the load of, which is the pressure from the building weight, is less than this value here. Once it is less than the value of the soil bearing capacity pressure, then your foundation is okay. Now, as you can see here, we have 77. You can see there, and then our maximum here is 76.9. And if you check very well, if you can zoom this very well, you will see that this maximum here may not be directly on the area of the building. It can just be at the edge of the perimeter of the building. Let me just zoom up. Okay, so when you're trying to zoom up this right now, you will see that it will begin to cease as if your system is like hanging. So the whole idea, just to be fast, is just for you to collect this, just get the maximum of this, and then locate this maximum here for the soil. So once this value here, which is the maximum, is less than the value here, then your foundation is okay. So in this case right now, we have 76.9 here, and then we have 77 here. So with this right now, this foundation is okay. So the load, the soil pressure due to the weight of the building is less, as you can see here, 76 is less than the soil pressure due to the bearing capacity. So with this right now, this foundation is perfectly okay. Now, if it was failing, there is something you would do. Okay, so right now, we don't expose that here on Ekidel. This is a free channel or free YouTube channel, but if you come to if you are able to enroll for our Ekidel mentorship class, we will teach you all the details that you are meant to know. Okay, so right now I've just showed you how to design for a simple Raft foundation. So right now we are not going to move in right now to close up to this stage and then begin to check for our Raft foundation slab reinforcement. Now this is also shown export contour. There is a stage, there are sometimes you have to export these contours, but not on these. But that's if you're doing a very massive building, then this must be a must for you to export. Okay, but for now, since this is a small building, I'll just go ahead and then click on this just now. Okay, so click on this. Now, the reason why we advise people to enroll for our mentorship program is because there are some things, since this is a free channel, there are some things we might not be able to say everything. But on our mentorship program, we train you very well and show you all the secrets and details to perform to be a good structural engineer or a civil engineer. Okay, so right now you can now click on this place right now. So click on you have to click on this place here, say okay. So I'll click on okay and then wait for you to now transfer all the slab strip, which is the slab reinforcement, onto the very model. So once you read this stage, just hold on. Once this stage begin to read, you will begin to see the values here will begin to read. So just hold on for it to start. I say again, don't click on anywhere, because once you click on anywhere, it will make your system to slow or to hang, and most times the software can just shut down. And if the software shut down at this very stage now, as we are here right now, everything you have done has lost. You will lose them because we have not saved anything, and you cannot save on this place. This place, if you want to save here, it will not going to save the main Prota software of your model. So you can now see that we are now on the strip 1. So we wait for this strip 1 to finish, and then it now enters strip 2. Okay, now we are now on the Y1, as you can see it here. Then wait for it to end to finish. So that's how it will read till it finishes X2 and X3. Okay, so once this is done, it will now move it back to the next stage, which you now transfer the load of the slab onto the ground beam, and then we will now go and design our ground beam. Okay, So let me just hold on for that stage to just complete right now, and then we'll now move on to the next stage. Okay, this is the last stage now. It's almost ending. You can see how it's reading here. Like I said before, once this stage starts, this place will start reading. Okay, so right now, so on this stage right now, don't just go ahead and close. You have to transfer the foundation beam result into the beam, into these ground beams. So I'll say now transfer foundation beam result. I can see right now they will tell you here that foundation beam finite element result are transferred. So right now we can now close this stage just now. Now once you close right now, you can now see that we have already done strip right now. So since we have already designed our Raft Foundation right now, we can now right click here to now see the slab, the Raft Foundation reinforcement slab. We can now just right click here and then go here and then say update T-bars. Okay, and wait for it to finish up just now. It will take like some few seconds to show these T-bars. Okay, so right now we can now move on. Once it is shown, okay, so you can now see our slab. You can now see it, right? So it is showing that we are to use Y16 for the Raft Foundation. Okay, let me see if we didn't choose Y12. So let me go and check for this place. And sorry, we have to go and assign Y12 for that for our slab detailing. I think we didn't use Y12, so that's why it's showing just Y16. So let me go and check first. But although this building is a very big one, so if we see and that it's already assigned Y12, so and it's choosing Y16, that means Y16, because remember we had on that place called area of steel, we have our area of steel to be 1,200 and something. So if you compare it to what to your slab table, you will see that it is falling directly on the Y16. But let's see first if we assigned for foundation to use Y16 alone and not Y12. Okay, let this stage just pass and then we'll go and check that right now. So we go to this place right now, this place here, analysis, sorry, on the here, and then go to edit material and then go to foundation floors. Let it come up. It's coming up just now. Okay, foundation floors, and then go to this place, rebar diameter, and then okay, can I see that we have only 16, so we have to go assign 12 here. So we'll choose 12 as you can see it here right now, and then say okay, and then say okay again, and then say close. So with this right now, I'll just go here, right click here, and then again and say update T-bars, and then check if it will use try 12. Wait for it to finish up. It's still trying to load. Okay, so okay, now that's fine. So you can now see that it's not showing us Y12. Okay, that's fine. So you can now see that all our slab reinforcement right now is for the Raft Foundation is giving us Y12, and some parts spacing is 125 and some is 250. Although we can use 200 here on this place showing 250, and we also have some parts. Okay, almost every part is showing 200 except this one that we saw here, which is where is that 125 here. Okay, that's fine. So we have to take note of this here and then take note of this. Okay, this one is 200. Okay, that's fine. So we will have to export this to the template, which is the customized Prota detailing template, which is called the stone bridge template, which I will also use. So you can now see how we have designed for our Raft Foundation. Now we want to now design for this beam because this beam have not yet been designed. So we have to now go to this place here. To this, let me go and assign first for our. We have to go and assign first for also our beam reinforcement. So let's just save this first. Let's save this right now. So you can now see, so you have seen how we have produced our Raft Foundation reinforcement for the slab. That's how to produce the Raft Foundation for the slab. Okay, so let's now go and design for the beam, because all what we have done so far is just for the slab. It's just for the slab design, and also to now transfer the load from the slab onto the beam. Okay, so right now we will now have to now go and design for the beam, especially which I'm going to use a batch mode design for the beam. Okay, let me just finish. Let this stage just round up just now, and for us to move to the next stage.
Okay, now the part 3 of this building of this design will be on the detailing, because we have told the client that we want to issue this issue this job to him by next week. So that's why we are trying to finish up this just now. Okay, so right now go here right now and then say edit, and then check my beams, and then check my beams, my beam reinforcement, and then assign. Okay, I want to use minimum 16 and maximum 20. That's fine. I'll say okay, and then just say okay here, and then just say close. That's fine. So right now, once you're done updating your steel bars after you're done with the designing for your slab, you can now go right now to now go and check here settings here, and then sorry, not settings, on this place here, concrete member as concrete design, as you can see it here, and then go to this place here, and then go to foundation beams here, and then a little box will appear where you have to put some settings. So you can see that all our beams are failing. Put on the foundation, you can see that F means foundation beam, so it is failing. That's how it is to show. So right now you have to now go to this place, click first on this place. Now listen here very attentively. If you don't do these settings here, there is no way your beam will design. If you don't put these cover values, it will not design. And you put your cover values on this sequence. You put for the edge 35, and then you put here 50, and then here 35. If you don't put this value this way for your cover, this beam will not design. Okay, so right now you now go again right now, and then go to this place here, parameters, and on these parameters right now, you click here and then choose your minimum bar for the beam, which is 16, and then maximum to be 12. If you don't check this, there is no way this beam will design, not in heaven and earth. Okay, so you click here again right now, and then choose your maximum length. Just choose 12, but the design will use 10, which is the minimum, but you have to choose here first as minimum and maximum. So the whole idea is to choose your minimum steel and maximum steel, and for length also minimum steel for length and maximum length also. Now once you've done that right now, you now click on this place here called save. It will share you this this message. Just say yes, save. Now it has not changed to these settings which you have done for the beams, which is just for the foundation beam. Now on this right now, you can now go ahead and now click on this place here called batch mode design. So click on this place right now, and then check this first one here, check steel, select new steel when previous bar are insufficient. That's fine, and then click on this place here called calculate. Then you wait for it to design for the beams. Now once you're done designing, you will see that all these things will like mark, not all actually, but few of them or all of them will like mark green good. Now once it has marked, you will now begin to check each of the beams, which I've taught you before, which I've taught you on the structure, what they call interactive design. So once few of them are being designed, we will now begin to check for interactive design, where we will have to check for the beams one by one. Okay, that's fine. So right now you can now see that all the beams has been ticked good. So you can now begin to check for the beams one by one. So just click here and then double click on each of the beams. Once it opens just now, you will now see the beam internal area. So this is how so I want to use 20 is too big for me, and also it will make the beam to be very expensive. So I'll just increase the bar to 3x16 and reduce from 20, remove here, and then increase here. So I'll also reduce here and then increase here, and then also on this place right now, I'm gonna remove this right now, and then remove this also. And then I'll also come here right now. Now this thing is this reinforcement need to lap into this place. You can see that this red thing here means failure, and this also means failure. So right now I'm gonna lap this reinforcement right now into this column. So I'll go here right now and click on this place and say lap, extend right to lap. Now reduce this first to 16 and increase to 3, it will pass, and then come here again right now, and then lap left to lap, and then lap here also to lap, and then decrease here and then increase here, and then come here again right now, and then click here and then say here lap, and then decrease and then increase. So this is how you are meant to set for your Raft foundation. Most people do mistake and to leave support bars here. That will give you a rubbish when it will give you a rubbish detailing after you've exported your beam details. It will give you rubbish. So this is how you have to arrange it. Now this is the reason why we say if you can afford for our special training, you should afford it. For now, right now we are giving discount. It's not expensive, $300, which you can pay
for 3 installments, and it is just a 4 weeks intensive program. Sorry, training, yeah, program training. So we have to train you very well. Now you have seen what we have done so far on this beam. Most of you will just go ahead and leave it the same way as it was, which is not okay. So this is how you are meant to arrange your beams. Now there might be some things which we are not which we are not saying, because we don't want this video duration to be very long. That's why we advise, as you watch our free video, when you have made money or try or raise some money, I'll say you should enroll for our special training. We are not gonna you are not helping us. We are trying to impart what we know into you, and which we have already done so far on our free channel. Okay, so right now we have to now click on this place, say okay. So if you're interested, I'll say you should check on the link down below and then enroll for that. Okay, so right now it is now that we have now said that this first beam here has been designed for, because we have checked it. That's why it is called interactive design, as you can see it here. So you as a civil engineer, or you as a civil engineer or a good structural engineer, is meant to check the software to see the kind of reinforcement the software used to design for your members. So right now we check on this again. So always you have to check for the beams one by one to be able to be sure what the beam reinforcement will be at the end of everything. So right now, if you can export this right now as your beam result, you have seen that all the reinforcements are not arranged. You see a messed up detailing. So right now you have to arrange it by yourself. That's why it is called a software. Someone programmed this, and those people also make mistake. Okay, so right now you have to now decrease here and then increase the number of the reinforcement, and then decrease here and then increase here and then decrease here and increase here, and then remove this entirely from support, and then remove this also from support, and then go here right now and lap this first, lap this here, and then decrease here and then increase here, and then go here, lap left and right. You must lap, else you will see your detailing as a messed up. And that's why most people say this software is not good, because they don't know how to use it. Okay, so right now you have to increase here again the number of reinforcement, and then go and check again on this place. Come here, decrease the number, the diameter, and then increase. When you decrease, there will be a failure. This red thing here means failure. If you can print out your drawing like this building will collapse. So you have to increase to make sure that there is no red here, and also there is no red here. So here right now, remove this also entirely, and then come here and then lap this place right now into this, and then reduce the diameter and then increase the number. Okay, that's fine. Now remove this entirely just now. Okay, now when you try to remove, sometimes it's not going to remove, but this bar is already off. So if we say okay and then come back again and then check it right now, you will see that bar has already gone out. Okay, so you can now see that is out. So this is how your bars will look like. You have 3 numbers up and 3 numbers down. This one is called a web reinforcement, which is also called a sidebar. Now once your beam once your beam depth is more than 600, you will begin to see this kind of sidebar, because that is now called a deep beam, and this beam depth is already 1.4. so that's why we are having these sidebars at the side of the beams. Okay, that's fine. So right now we only touch the top bar and the bottom bar, and leave this sidebar as default as it is. So right now click on OK. So you are meant to check each of the beams one by one. So you can now see that once you have checked, I have checked 1 and 2, so you are meant to check all of them. Let me check this one again right now for you. But the whole idea is that before you say you're done, you are meant to do all the check-ins of what I'm doing just now for all these foundation beams. So you are meant to check them and reduce the bars if you don't want how they are. Make sure you have only the bottom and the top. Leave all this, take off all these support bars here. They will make your beam detailing to be a messed up, and it will not look nice. Okay, so I will also come here, lap this one just now, and then reduce the bar, and then increase the number of the bar, and then come here again, the same thing again, lap again, lap left and lap right, and then come here again and then do the same thing here, and then come here again right now, lap left and then lap right, and then reduce the size of the bar and then increase the number of the bar. Okay, so right now again, I'll go again just now, remove this one entirely, and then come here again, come here right now, reduce the bar diameter and increase the number to 3. Now our 3 is still failing, so I'll make it to be 4. Okay, 3, don't worry, 3 is okay, but at the bottom here, I need to lap it to stop this failure here. So I'll come here right now, lap it here, reduce the diameter of the bar, and then increase the number. And this place here, I'll just, let me check again. Okay, that's fine. Now this place right now, here right now, since you already removed it, it has gone off. But once you say okay and then come back, you will see it again. So I'll say okay right now, and then come back to the beam again, and then check. You will see that beam, that support bar is off. So you cannot see that it's off because it was there before. So right now, this is how your Raft Foundation beam is meant to be arranged, where you have to have the top, or just the top, and the bottom. The top reinforcement, which is here, as you can see there, and the main bottom reinforcement, as you can see it here. So this is the main top reinforcement and the main bottom reinforcement, and then your sidebar. So this is the 3 bars you're meant to have: top bar, bottom bar, and sidebar. So you cannot see. Now, if you print out this, if you now produce out this beam detailing, which you will see in on the part 3 of this video, you will see how it will look like, perfectly and sweet. Okay, so right now I want to go here and click on OK. So I will urge you to use the same that example which you're using on design right now. Check all your beams, check all your beams one after the other. I'm going to pause video and then check that. The reason why I'm stopping is to make sure that this video duration does not pass at least 1 hour or it's less than 1 hour. If not, I would have checked all of them. But to do that, doing all just now will take much time for me, which I don't want to do. Take more time. And if I continue doing it, it will look boring because you will see that it is the same thing which I'm just doing just now. So the whole idea is for you to check the beams and do just what I'm doing just now. Reduce the size and then increase the number once it's failing. Now, once you reduce the size, there will be a failure. This thing here means failure, here means failure. So you have to now increase the bar number for you to be able to pass, and then it is okay with this. So you can go here right now, click on OK, and then go. Let me just go again. It's just you can see that it's just like it's just like tempting me to continue checking the bars, but I will not, because I have to stop these videos so that I'll save the duration, because the cost of making these videos and also uploading it on this YouTube, and when and each of the size of these videos, some of them is about 1 gig, 2 gig, and it's very expensive. Most time we spend much money to just buy data and then upload all these files. Okay, so so there is also a free link, because we are trying to create a website for Ekidel just to serve you better. So there is a free link for donation, which you just put the amount which you want to help us and then assist us to support us to get this Ekidel website. So if maybe you want to support us, I will share you will see the link down below, say donate. So you can donate any amount of your choice and then help us to create this website, because we want to get the website this year. That is one of our that is one of our this year agenda on Ekidel, to have a website for Ekidel, so that we can help you better, because there are some things which we are meant to do that we cannot do it here on YouTube, and those things will also help to serve you better. Okay, so right now, go here right now and then reduce this and increase it. So if you love Ekidel, I'll say you should just use the support link and then support us to get that website. Okay, so let me just go again right now and then reduce this also, and then lap this first. Always lap, these two must be at lap, and then increase this here. Okay, that's fine. So you can now see that there is nothing showing red on this side and also on this side. As you can see it here, everything here becomes very okay. So with this right now, I'll say okay. Now I'll have to stop here, but you have to check all your beams. Always check all your beams. That is an instruction, else you begin to have issues on your building design. Okay, so right now this is the way to perform a Raft Foundation. So we have done it very, very full. And also on the part 3, we will produce the beam result, and also okay, let me just show you how to produce the beam result right now. So to produce a beam result, I'll just click on this place here and then click on design report, and then wait for it to load the next stage. So right now I'm trying to produce the the beam design report. So once I click here, you have to wait for it to load. I'll just go here right now and click on this place, say load legacy for beam design, and then click on this place here, say okay. And then once I click on okay, I have to wait for this thing to read. As you can see that it is trying to read to 31. So I'll wait for it to finish up right now, as I'm doing just now. Okay, so you can now see that this is now the beam design report. I can see it there. So this is the beam design report for foundation, as you can see there right now. So this is how to produce your beam. So you can also see our beam reinforcement, as you can see there from the report. Top reinforcement 3Y16 and the bottom 3Y16, and sidebars you can see there are 5. So this is how to produce the beam design report. If you check all what we have done so far, you'll be seeing that. And also you can also see for this differential check, it is okay, and okay. And also for the link reinforcement, Y10 at 300 spacing, as you can see there. So this is how your beam design report should look like. Very perfect. That's why I say you have to check your beams one after the other. So you can choose to just send it to like PDF immediately, or you can choose to print. For like PDF, you can just click on this place called PDF and then wait for it to load for PDF. And then once it has loaded, you can now go ahead right now and then move to that. Okay, so let us hold on for it to load for the PDF just now. Okay, it's taking longer time because it will have to go open it on the software. Okay, so let me just go here right now and then close this first. So that's just how to produce your beam design report for Raft Foundation. And then with this right now, I'll go here right now and click on this place to say close here. Now on the closing right now, to now produce your slab Raft, your slab report also, go to this place here. To this place here, which is the foundation here, which is this place here. On this place, click on this place, right click, and then say slab analysis and design to produce the slab report for this Raft Foundation. So click on this place just now, and then on this place right now, click on this place, just go here and then click on this place here, say design, and then wait for it to load up. So once it for the slab strip to for the report to like load up. Okay, they just hold on for it to come out just now, and then it will be out just now. Okay, the reason why I didn't check here is because I've already checked that before, and we have already designed our slab and showed our slab reinforcement. So right now I'm trying to produce the foundation slab reports. Okay, so let me just hold on for it to come out just now. Okay, so you cannot say that this year we have tried. Last year we didn't do much on Raft Foundation because we were trying to deal with pad foundation. And if you check our video last year 2022, we did more video on pad foundation. So we have treated all aspects of pad foundation, and this year we will be doing a Raft Foundation for buildings on Raft Foundation, and also for white strip foundation. And then later this year, at the end of this year, we will not introduce Pi, which will not go more full on Pi foundation on the year 2024, and then we will not begin to design for high-rise building for up to 10-story, 15-story, 20-story building for 2024. Okay, so Ekidel here, we have a lot of packages to train future civil and structural engineer. Like I told you before, here is where students, after your studies in your various schools or college or high schools, or let me say university, you have to now come to this place and then brush up yourself on Ekidel. Okay, so right now you can now see our slab report. So this is what you know that your slab report is okay. You will begin to see this thing sufficient. If it's not sufficient, you will see insufficient. So you will begin to see it, and also see your slab deflection check and see that L over D it is insufficient, as you can see there, and also see your slab reinforcement. This is showing Y12 at 250 spacing bottom, and this is also showing Y12 at 250 spacing top. So this is how it looks like. So you can choose to send to like PDF or print, or this one Microsoft Word, or even image. So right now I'll just go here right now and then click on close. You can choose to send to PDF if you want. So I will go here right now and click on close here. And then this one was opening for the bin. As you can see that this is now time for the one that we did for bin to open. So this is how you cannot see that it has come. Let me just increase the zoom, the visibility. Okay, so you cannot see for the beam. So we have now transferred it onto PDF. As you can see there, foundation beam design PDF. As you can see there right now, school building, as you can see. So this is now the foundation, as you can see there right now. So this is how it looks like. So you can choose to print also or save immediately on your system, and then but we'll just go here right now and close this right now, and then cancel this also. So if I check on our 3D view right now, we have come to the end of this part 2, which is the Raft Foundation design. So you cannot see what we have just done so far by designing perfectly this Raft Foundation. So this is how to design a Raft Foundation in Protastructure. This is the full one. Now on the part 3, we will be going into foundation detailing, where you will see, I will show you how to connect this two slab and this being reinforcement together, and also with the top this slab reinforcement here. So I will show you also on that, and I will be using the Stonebridge company template release 2023. Now Stonebridge has two templates. It has last year, which is 2022. Now the one that you'll be able to see or use for Raft Foundation and for Pi Foundation and for Pi Foundation and for all type of foundation is the release 2023. So if you want that, check on the link down below and download that template, because on the part 3, that is what I'll be using for the slab detailing for this building entirely. Yeah, I'll have to detail for the columns also. I'll show you everything about that, and then you will see how this template will help us to perform the slab detailing after Protastructure, and also to perform the foot detailing after Protastructure design. Okay, so right now, thank you so much and God bless you. We love you, and if you have any questions so far, I will say you should check on the link down below, and then comment your questions so far. And please, like I said again, our vision this year is to launch a software for Ekidel. Is to launch a website for Ekidel. In that course, it will make us spend a lot of money to launch that. So we have just created a link which is like a support link. So if maybe you love Ekidel and then you want us to continue what we are doing, I would say you should please use the link below and then support us. You have to put the amount which you want to support by yourself. It is like an open price area where you have to put the amount which you want to support us, and we will be very, very glad to have your support. So thank you so much and God bless you. We love you, and see you again tomorrow for the part 3 of this Raft Foundation design. So thank you and goodbye.